Okay, let's go. One LeetCode problem during lunch. Alright. Remove duplicates from sorted list. Okay. Given the head of linked list, delete all duplicates. Return. Okay. Sorted as well. Okay, we need to return the head. Okay. Okay, so we need to be changing up some pointers. Let's see. So we start from the head node and we need to check the value. If it's the same, we wanna just keep this pointer pointing next and then go to the next one until we get one that's not the same. Then we do next that. Then we move on to the next loop. Okay, some trial and error here. We need to store the head node. Okay, let's just name it new head. Well, head is not null. Sometimes we need head next is not null. Sometimes we need head not null. So we just need to look at each case. So let's go with head not null first. We want to prepare. Okay. Maybe we want head next not null because we want to compare head next value with current value. Okay, so head is at 1, head next is not null. If they have the same value, then what do we do then? Head next is head next. Okay, let's try with that. So head next is not pointing to 2. Okay, and probably better to try with this example, which is longer. Okay, so 1 is not pointing to 2. And what do we want to do then? So what if this one is 1 as well? So now 1 is pointing to 1, and we want to compare the next one. So we don't want to move our head pointer directly to head next yet, unless we know the value is different. But we still need this pointer to be moving forward. Okay, we might need to have 2 pointers. One is still the one that's the start of the duplicate value, and then the other one is pointing to the next that's not a duplicate. Then we connect them, then we move on to the next pair, and we move the pointer along until we get a non-duplicate. So we are looking at 2 pointers now. If that's necessary. Okay. Node is head next. If node is not null, let's see. If node value is the same as head value, then if it's the same, we wanna, so head is here, node is here. If we found a duplicate, we move the node pointer to the next one. Now head is pointing at 1, node is pointing at 2. They are not the same value, else. So it's now safe to connect them. So head next is 2. And the head is now pointing to node, and node can move on to the next one, which is repetitive, so we could take out that part. Let's just see if this will work first. So head here, node here, head here, node here. Head next is node. Head is now pointing at 2. Node is pointing to 3. Node is not null. Not the same. So head points to 3. Okay. Node points to 3. Node is not null. They are the same. So node pointing to null. Okay. And that's the end of the linked list. Okay, it seems to be working. Oh, okay. Three. So when head was here, node was here. We moved head to 3. Okay, that's the problem. So head is not pointing at 3, node is pointing at 3. And they are both still in the list. So when we are putting at 2 and 3, how do we ensure that we don't move ahead yet? Okay, so instead of doing that, we can also do one head is at 3 and node is at 3. So in here, we are now only doing node is not next, but we failed to do head next is node, which will link this next to a null node, which is what we need. So we are missing one step to handle when is the end of the linked list. Okay, so one node next is null, which means one is at the end of the linked list. Okay, so this solution works even though I'm really not liking the code as it is right now. It just doesn't look as clean as it should be. Okay, we are using 2 pointers, head and node in this algorithm. We're comparing them. Alright, we're gonna do some refactoring since we have some duplicate code here. Okay, let's do that. So same value. So no matter which value, so in both cases we need to do node is node next. Could we factor that out? Okay, need to rewrite this part. So if they're not the same value, then we are doing head next is node, but that's already after we are doing node next. So head next is node next, head is node. So in this case then, head next is node next. Oh wait, head next is node next. If node is null, head next is null, head next is node. Okay, so if they are not the same value, okay, for this example, they are the same value, so we're just moving node to node next. And then now they're not the same value, so head next is now pointing to node next. But node is actually pointing to okay, head next is not pointing to node, head is node, node is node next. So head is here, node is here. Okay, not the same value, so head next is node. Okay, head is not here, node is not here. Okay, and still not null, so they are the same value. Node is node next, which is null, head is here, node is null. If node is null, head next is node, which is null. So it seems like that should be working. Okay, hey, that's pretty good. That's pretty good runtime. First solution was not so bad either. Oh, this is definitely one of the better ones I've seen. Okay, it is an easy problem. So we have refactored. Anything else we could do? Okay, what if... Okay, we still need this. We need this to return the new head. We need this to be the extra pointer. Okay, I am happy with this solution. Let's do complexity. So we are traversing the linked list once, just going forward. So time complexity would be linear to the size of the linked list, and space complexity would be constant because we're just using 2 pointers and nothing else. So constant space, linear time. Linked list, questions. Okay, I guess we could do the next one. me do sorted list. Okay, sorted list 2, we can do that next. Wow, 3 lines. Okay. Oh, it's recursive. Okay. Okay, I have to pause here and I will continue with looking at other solutions in the next part. I have to go back to work. Okay.